Yes. Good evening, everyone. This is Dr. Rakesh Naik from Vaagdevi Engineering College. Today we are conducting this session with Bala Prasad Peddagari garu. He is a principal consultant, technology head and digital initiatives. He is secretary of IEEE Hyderabad section. This before fully introducing the essence of this webinar is that because many people are aspirants for BTech computer science, BTech artificial intelligence, machine learning, and BTech data science, IoT. All these peoples are getting confused with the things that which subject to choose. So the main purpose of this webinar is that Dr. Balaguri will enlighten us in this regard. Basically, his credential are very long. As I told you, he is a he is from Tata Consultancies Private Limited. Sorry, TCS. He is the right person to guide us in this regard. And apart from this, he is involved with many societies, like he worked as a secretary IEEE Hyderabad section, IEEE Computer Society Hyderabad section, is past chairman, then managing committee member of Computer Society of India Hyderabad chapter, Open Group Board India EA member, and Computer Measure Group India founding board members. And apart from that, he is having many to his credit. His specializations are on enterprise architecture, microservices, API management, and API management, cloud business solution, performance engineering, and tuning. Windows, Azure, Visual Studio 2012, ALM, SQL Server 2012, Windows 8, .NET framework, and there are many more. He has written many articles, and he is a very active person in all these regards. So without wasting much of the time, I'll hand over this session to Mr. Bala Prasad sir.
Thank you, Rakesh. Good evening to all of you. Very glad to meet you through this particular platform to share some of the importance of data in the journey of enterprise, in the context of enterprise. Why data is so important. We have witnessed over the years now, and we are now witnessing in the current context, data is the 21st century oil. There is also saying that whoever has the content is a king. The combination of the data and the content makes us more powerful than ever. So having said that, let me start out with describing some of the importance of the applications of the big data, deep learning, and data science. You often hear these three terms interchangeably used by few people. But there is a subtle variance associated to all these three areas and the applications of this. It is very, very critical and important if you really want to make a career out of these three areas. You need to understand the difference associated, and you should know where and how these particular things will be applied. So knowing the applications will really energize you to think in that direction and also assess the coming opportunities, which will be really transforming the journey of enterprises to a next week. In fact, as I speak, many enterprises, if you are going and asking what is your highest research investment and where are you spending more money, they normally try to give that we are trying to spend more money analyzing our data, drawing intelligence from the data, deriving the insights from the data, and using that particular insights to formulate our next investments which we need to make on products or innovations or even the services under which we need to operate. So let's witness what these applications of the big data, deep learning, and data science is all about. So as I want to communicate to you, I just want to start with this particular graph. So as we start the understanding, there is a huge amount of complexity gets generated when your volume of business goes in. As the time progresses, the business processes and the data which gets come in also will be very, very highly complex. Now, as the data becomes more complex, it becomes even more difficult for you to make the decisions. So decisions need to be made not only with one single parameter, but there would be multiple variable parameters which will be playing a role. So how do you manage these things? How do you try to analyze these things so that you can really make a bigger impact? Because the decision making burden can be done to an extent. After that, you fall apart. You will not be able to move the needle, because the ability to analyze, ability to compute, and ability to recommend will be even more difficult for the complex situations you are trying to go in. It's primarily because you have led to the level of the analytic maturity, and there is nothing much beyond that you want to can make it. But there is a road ahead, and that road ahead tries to talk about how this data has been grown and how the data analysis and data maturity has been changed over the period of time. You are witnessing that there is a huge amount of shift in the data analysis is going on. Earlier, probably in the last 10 years, decade ago, you can see that there is a lot of amount of focus was given on the descriptive data intelligence, which is trying to talk about how you try to describe and analyze the outcomes. More importantly, they are trying to talk about the advanced BI. This is nothing new, because it is trying to look into the terms of what is there in the context of the data and trying to come out with the analysis based on the data what they're witnessing. And you see there is a lot of reporting, dashboards, scorecards which are generated out of that. So organizations and enterprises were able to properly leverage that. But that is not sufficient, because business really want to know not what happened, they want to know what will happen in the future. So there is a necessary future course of actions they can take. They can identify the possible outcomes. And that's where some of the new initiatives has emerged, where people were able to mine the content, analyze the content, predict, model, utilize some of the probability and statistic techniques to really analyze and demonstrate it visually, so that we'll be able to drill down into the things and make the meaningful decisions about our investments, about our recommendations, about our path to take to make the prediction to come true. So that's where you see the forecasting and domain expertise coming in. Let me give you an example. In the pandemic situation, which has resulted because of the COVID-19, there is a huge effect happened on the demands and supply chain. Primarily because there are many enterprises have shut down. But yet you see that people were able to predict this kind of situation ahead of time, looking into the market conditions of what is happening in China, looking into the conditions what is happening in the Italy, France, and other sectors, other countries, which eventually helped them to mobilize their resources in the right way and try to ensure their demand planning and supply planning were able to manage the outcomes better and efficiently. That is primarily because of their planning modules which are there in the ERP ecosystems. These predictions are very strong, and that's where the advanced analytics are playing an important role in predicting the things. Is that really sufficient in the today's dynamics, where we try to talk about artificial intelligence, where we try to talk about big data, there is a structured, unstructured data which is playing a role? Probably not. I don't want to get predicted. Businesses today are demanding that you don't tell me that where my sales will go in the next 2 months. You tell me if I want 25% of my sales increase, what should be the actions I need to take to make it happen? That's where the prescriptive analytics is coming in, where it's not only predicting it, but to achieve the desired outcome, what is the next best action I need to take? So there are models which are getting simulated, and that simulated models are able to come out with the predicted results. So that's the reason you could see many companies like Infosys or Wipro, they try to give you the future guidance, because they are able to prescribe and take the necessary action for the future. So the quarterly reports, what you try to see, it's because of that kind of a prescriptive action they have in knowledge. They exactly know where the entire trend is going on and what kind of steps they will take to achieve their particular trend. If I want to have an improvement in margin, if I want to increase my top line, if I want to increase my bottom line, that is a profit, revenue and profit, you exactly know what measures and what services you need to launch, which customers you need to tap in, where do you want to go. These are primarily driven because of the evolution of the AI into the mainstream and the kind of cognitive systems which are getting built. and the ability to apply the machine learning, deep learning models to the structured, unstructured data and combine with the strengths of the domain intelligence to make it happen. As I say, it is important that this shift has got a lot amount of foresight into the future. So there is a huge amount of need for us to take future thinking and dig deep into that. Today, if you're trying to look at, you only try to project the growth rate based on the kind of a trajectory volumes. But there is always a possibility that you underestimate the future because you are not knowing about what will happen in the future. And because you may not even time the things, you may not even predict the kind of situations which will result in. Nobody predicted the lockdown in India. Nobody predicted the lockdown in India will go on for almost like 6 to 8 months. Nobody really predicted that situation will be so worse that the businesses are almost shut down in some areas. So it's important that you take this kind of a prediction and take the right level of measures. What about the kind of a rains which happened in Hyderabad or in Warangal? Even though we have a predictions talks about the rains, but the volume of rains and how much has disrupted the human lives also has an effect. So ability to take the prescribed action, looking into the trend, looking into the projections is very critical for even for the government sector. If they take the right level of actions and following the prescriptions, they could avoid that kind of a situations and make the common man survive in such kind of a stressful scenarios. Let me run you through some of the historical aspects which will give you a kind of a perspective of what the data intensive decision making is all about. You see, in the early 1960s, there is a huge amount of focus was given on the business intelligence because primarily we were driven with the decision support systems which are really causing the impact for the organizations to survive and sustain. But in the 1990s, when the business intelligence has been really developed, it's very important for them to mind the things. The decision support systems are really migrated or moved into the BI space where we are able to slice and dice the entities or the data, which was able to give us a descriptive and predictive outcomes. Later, we have seen in 2000s, but that is a decade where the analytics played the dominant force, which was able to come out and predict the things. And not only limiting to that, because of the internet and because of the IoT sensor data, the volume of data which is getting triggered from the different sources was exponentially grown. And this demanded for us a huge processing power, huge analytical power. And the ability to predict has been constantly getting challenged and getting transformed into the prescription mode. And that's where the big data analytics dealing with the structured, unstructured, and semi-structured data was part of the real time. The future is all about this. So you are dealing with the types of the data, and there are different kinds of technologies which is really evolved to solve some of the key and core problems associated to the enterprises living in today. Now, let me provide some kind of a implementation details and give you a kind of a stack which is playing an important role. So traditionally, you know that we are working on a structured data where we have a lot of legacy systems and also the enterprise systems like CRM, customer relationship management, enterprise resource planning, legacy applications, third-party applications. They are all part of the data warehouse systems. It's a kind of a lot of data which comes in the flat files, a lot of data which is coming from the different data sources. You use the extract, transform, load kind of a concept to put into the data warehouse. Further, that you try to visually analyze through the reporting and visualization modules. But these are all part of the structure. But today, if you're asking, or the future when you're demanding, you are trying to live in the unstructured and semi-structured world. It's not difficult that to process them, but it is important that you need to process it at a very real time. So when you're looking into the semi-structured data, you need to look into the huge amount of application logs, web logs, volume logs, so you can correlate and associate. When you're trying to look into the unstructured data, you also look into the weather data, social media data, but the Twitter feeds which are coming in, the kind of a documents, text, images, voices, all these things plays an important role, and that's where the evolution of the MapReduce and algorithms and also the Hadoop clusters played an important role to do the things at a faster pace and understand the things in a real time or near real time so that you can predict the future and prescribe the things which can ensure that you are in that direction. These are the basics which are very, very critical and important for you to understand as part of why big data is getting complemented with the existing analytics. Over and above, you see today in the organizations, like in fact, my team itself is working in building the enterprise data lake stores. So just like uh, you've been part of the Varangal, just want to touch upon for the Vaagdevi people. Varangal is a city of lakes, according to me. There are many lakes, right? Where you are trying to get the lot of water pulled in for the agriculture sector. Similarly, when the data is flowing from the different stores, you try to form the enterprise data lakes. Small data lakes you can create, and you can have the data scientists who will be working on that particular data lake to define the models, validate the models. If it's really making sense, they use the models. Otherwise, they will discard them and create a new model. So data lake is becoming a very important source where different those data sources will subscribe to share that information that goes into the lake, and the data science plays an important role to analyze it. And once that analyst or data science plays the right algorithms in place, the data consumption store or the reporting modules will kick in to report and visualize this particular data. And these are becoming a dominant force behind all the kind of predictions and prescriptions what we are trying to do. In fact, from the enterprise data lake, there is an advancement which is happening today. People are trying to monetize the data. And one of the important areas, if you have the data, you can also monetize the data using the data as a service concept. Just like anything as a service, data as a service is becoming very important thing. Like payroll data as a service, the citizen data as a service, sports data as a service. So many kind of a data which are getting as a service modules. In fact, I encourage people who are really wanted to become as part of the data science aspirants or the who are very much acquainted with the data to go around with Kaggle. Kaggle is a website which throws huge number of challenges for the data scientists, and they also get paid for some of the problems we try to solve. You can utilize Kaggle as a source to subscribe to some of the problems. They provide you the data sets for you to experiment and try to develop the modules to solve those particular tree problems. As I say, just be introduced to the platforms and technologies where actually the data management is playing a role, where actually the the stream and content which is playing a role in this entire journey. So you see there is a huge amount of logs, SQLs, NoSQL, MapReduce, real-time analytics. All these things are horizontally available, but these are the set of tools and technologies which are available for you to consume. But what they intend to do is completely different. The first set of information is related to the ETL, that is a extract, that is collect, store, transform, and load. This will ensure that your data is moved from the different sources into the data lake or the data warehouse. But once you get there, it is important for you to model that particular data. That's where the data science comes in. So the data scientists are responsible for modeling the data, ensuring that they have an appropriate reasoning given out, and they have the ability to visualize them, see the fitment and the kind of decisions which is they're taking. And if the decisions are in favor of the business or further in the favor of the guidance what they are trying to achieve, they will certify the model. Otherwise, they discard the model. So that it is a continuous iteration process till they achieve the real thing. So there is a lot amount of exploration which is required for them to look at it. Right from the reasoning to the transformation, it's a set of tools which are used by the data scientists. They play a very important role in this entire journey, especially in the visualization and reporting. In the subsequent slides, I'm going to touch upon some of the data science lifecycle stages, which will give you immense visibility about how you try to drive through this particular journey. As I say, I'm also trying to introduce to the entire landscape, then I will move on to the applications. It's very important that you know that a huge amount of landscape is associated in the big data and data science space. The first thing is related to the query-oriented data warehouse. There is huge amount of tools which are available in the marketplace, which plays an important role, like Cognos, Oracle, Teradata, and other things. And further to that, there is a distributed file systems and MapReduce algorithms which is playing a role, like Hadoop, Hortonworks, HD, MapR. All these things are there available to do this justice. And they all need to run on certain appliances which will play an important role. And over and above, there are tools which are trying to help you in driving the change, like Zookeeper and Uzi. They all play an important role when you're trying to work on these particular distributions to manage the things. And another segment of the tools which plays an important role in this entire platforms is data integration. So basically, you see there is a huge amount of visualization tools like Pentaho, Talent, and data integration tools like Informatica, Data Stage, which is trying to integrate the data from the different sources and get into the lake for us to analyze further. And for us to manage the data sets, you need to have certain languages like Python, Hive, Mahout, R. They play an important role for you to program the things, model the things, and using certain libraries. And since you need to work with the unstructured data sets, you need to also have the ability to play with the graph databases, NoSQL databases like Couch Database, HBase, Cassandra, and so on. And further to that, anything is possible, you can analyze, but nothing is visible till you have the visualization in place. So there is a lot of visualization tools plays an important role beyond the integration, which gives you an opportunity to drill down the things at different levels. So analytics and visualization plays an important role, but once you visualize, your ability to handle the complex event processing, which are continuously streaming the inputs or streaming the events or generating the data, and your ability to search the details and find out where actually you can discover the information is also critical. This is the overall landscape of the big data and data science one need to be aware of. Uh, don't say that I am trying to interchangeably use big data and data science. Both are different. And you need to be aware of the fact that big data is trying to help you analyze the unstructured data sources, and data science is trying to bring in the insights from the particular data sources. That's the main. And over and above, Google Trammel is an open Trammel which is there, which helps you to do the analysis at the faster level. Likewise, you also have the SAP HANA and many more things like Storm, which is producing the same thing. Having said that, I'm trying to touch upon what is a deep learning, which is a kind of a subfield within the entire context. So there is a lot of connections between the big data, data science, and machine learning and deep learning, all these things, which are all grounded and surrounded by the artificial intelligence as a concept. Right from the 1950s, you have seen artificial intelligence into the existence, but it is becoming a mainstream only in the last decade, where there is a huge emergence of the compute power was available for us to work, because it demanded a GPU based systems, which is easily available for the general consumption. Today, GPUs are in fact available even for our laptops. People can use the 16 GB GPU machines supported by the NVIDIA graphics to train around 1 million datasets or 10 million datasets at ease at a local, using the local processing power. Otherwise, people need to have a server scale capacity to achieve it. Now, why do you need a deep learning? Can't we engage or do the things without deep learning? You can certainly do it if the volumes are small in nature. But what happens if the volumes are growing? How do you validate the data science can scale with the amount of data which is growing? Very, very difficult. The older learning algorithms were not able to scale up to the level what we really wanted to. And that is where the deep learning really emerged. With the advent of lot of data which is coming in, there is a bigger models which need to be developed. There is a more compute power which need to come in. And it requires us to develop the best algorithms to derive and draw new insights, which will eventually help us to improve the technique to formulate the decisions. And that's where the deep learning is really making the things much more granular in nature. And our data science techniques, in fact, if you want to really utilize with the scale of the data, you need to have the huge processing capabilities as well. Now, just providing you the kind of insights of some of the applications which are very, very common in nature. I don't know whether you're aware of the fact that Google has developed the AlphaGo. It's a kind of a system which they have developed, which has learned by itself to beat the Go world champion. Go is a game in China, and this AlphaGo was developed to learn on its own. In fact, it has failed to beat the champion multiple times. Probably in the 10th variant, I believe they were able to successfully beat the champion. And they have not trained the model with the variety of the data. They made the model to learn on its own and make the intelligent steps. So it was called as a unsupervised learning method, where the model can learn by the kind of failures it encounters. Today, you see, deep learning is also engaged in a lot of image tracking area. The computer vision capabilities are all possible, where you try to teach the model, looking into the image, what would be the possible thing. So it will interpret the image based on the regions, based on the coverage of the image, and it will try to come out with the proper recommendations. You can see in the leopard section, there is a higher probability the image could be a leopard, but it is not also ruling out jaguar, cheetah, snow leopard, Egyptian cat, because it has got certain features within the regions where it is trying to prompt. Similarly, different image benchmarks you try to introduce and you try to arrive at the approximation. The more you train the model, the more the accuracy. Remember, in this entire deep learning engagement, the machine learning, there are three important metrics you need to calculate: accuracy, precision, and the recall rate. If the accuracy and precisions are good, the recall rate will be low. As long as your recall rate is low, you need not really worry about the algorithm. If the recall rate is high, you need to tune and optimize your algorithm to decrease the recall rate and improve the accuracy and precision. Today, you see in many of the media levels, lot of images or videos are getting captioned automatically. No user or no programmer is sitting and captioning the things. It's a AI-based systems which are captioning the things automatically and explaining the things. That's where you see there is explainable AI also coming into the existence. So power of AI, power of deep learning, power of data science combining together to form all this insightful intelligence associated to it. You can see many coloring of the photographs also can be done through this kind of a deep learning methods. So artistic styling is also can be possibly done with the deep learning methods. As I say, I also want to touch upon some of the why, what, for what purpose, where you are going to use this deep learning. So generally what happens is when you're traditionally looking into the data, structured data, you normally have a labeled data where you have the, if you are learned as part of the DBMS systems, you know about first, second, third normal form, and many of your data is sitting in the tables, and each table will have the column names and the rows which is formulated. So anything which is a labeled data is structured in nature, and you have the machine learning algorithms which you can manage to model it and do it. But these learned models can be used for predicting the future outcomes. And it is important that where do you apply these things? So then generally when you are looking into the data, you normally see the scenarios falling into the four categories. First category is trying to talk about the classification, where you have the nature of the data which can be classified into multiple buckets. You can say that I have a list of employees in an organization or a list of students. If I'm classifying in the college, I'll classify all the students in the form of first year, second year, third year, fourth year. So that is one form of classification because the nature of their belonging. Or I can classify based on the gender classification, or I can classify based on the percentage wise or the marks classification, first class, second class, third class. So second thing which you normally see as part of the supervised algorithm is a regression. Basically, if you are trying to plot the graph associated to the data, which would have a huge amount of variance, and if you want to discover the outliers in it, you normally follow the regression pattern so that it is easy for you to understand the quality of the data under which you are trying to operate. If your outliers are very less in nature, then your quality of data is good. If outliers are large in nature, then you cannot really make any kind of a meaningful sense. So the plotting of this particular data will really help you to arrive at the things. That's where you see supervised prediction. So it means you can train the model with a wide variety of the data sets, feed it in. The third category of scenario is all about the clustering, where you see that I can form the cluster of groups. And I can go on doing these levels of clusters, first level, second level, third level, as long as there is a huge amount of difference in the distance between the clusters. So that's where you use a centroid. If you have learned about in the mathematics, it's a centroid which will help you to arrive at the clustering differences. So fourth category is anomaly detection. The patterns where you try to see specific anomalies in the entire continuous series of data. This is generally used in the IoT sensors or time series informations, where the data is continuously flowing and you're trying to plot, and if there is any anomaly in that behavior, and if you spot it multiple times, then you try to investigate the reasons. And you see over the period of time, this particular algorithms are getting evolved, digitized model, and you see that computer vision, natural language processing, and speech recognition are becoming the integral part of this entire revolution, what is going on today. So these are all the frameworks or in a kind of a toolbox. It's not like a ready-made solution you can go and package it. You should utilize this particular package of information so that you can apply to the different applications and build the story accordingly. Today, every enterprise, big level organizations have started using deep learning methods to a great extent and also practicing data science to a great extent. There is no organization in the world which does not have a footprint of big data, deep learning, and data science today. Now, there is also emergence of the new frameworks developed by the different people. Bit.ai, Carbon.ai, Clarify.ai, Vicarious, SkyMind, Signal Sense, everyone is coming out with the new frameworks. OpenAI has been completely advanced. So they are trying to provide not only the intelligence but also making the things much more easy. In fact, there is a new technology which Google has introduced called Google Duplex, where I can make the conversational interfaces to be much intelligent using the Duplex technology and understand the nuances of the human-related conversations. So I don't know how many of you have seen, but if you can Google around Sundar Pichai's Google Duplex demo, where he tries to make the booking of a hotel table for a group of 3 or 5 people, you can see how it drives a conversation. How does a bot drives a conversation when he's trying to book a slot for haircut? So, which understands the conversations which goes at an expected pace, which understands and transforms the behavior of the conversation based on the unexpected phase also. Both the things it tries to handle with ease and manage the things. So there is a huge amount of landscape of technology platforms are evolving and getting used. It is not only the core technologies what you try to see, right from the AI to the speech recognition modules. There is also a lot of amount of focus is given today in terms of how the enterprises are rethinking their models, rethinking their entire campaigns, and driving their journeys. Even industries, every industry is rethinking and trying to transform. Otherwise, they know they could get disrupted in their industry. If they are not be ready with the kind of a change with analytics, big data, data science, deep learning engagements are bringing in, they are out of the game in very short interval of time. So making themselves available in that journey is becoming an integral part of their investment strategy as they go on. So this core technology is what you try to see has got a specific framework, specific tool sets which are always there. And you see that in the context of the ad campaigns or the media content playing together and transforming how the entire marketing will be changing the game plan for the different industry as we move forward. Now, having said that, I just want to come to the crux of the story of the data science and its benefits. It's very important because today you see that you know how to turn the data, how to analyze the data, but turning the data into actions is becoming an important element of the data science. And so if you really want to derive the insights, really wanted to make the insights tell the business and recommend the business what they need to do is what data science helps today. Salesforce, I came out with a Einstein as a data science analytics module. IBM has got their entire platform of Watson, which provides that kind of capabilities. Likewise, Google has their own platform, Amazon has their platform, Microsoft has a platform, which is providing you the immense capabilities associated to the data science. Now, who can use this data science? Any new age digital enterprises can use this data science, and anyone who is having the ability to incorporate all the advanced algorithms can use this data science for products or for the services. All the disruptors in the digital world are using this particular data science capabilities because it will really able to help them to develop the really needed features of the organization and make the game change and be part of the game changer, to be very honest. So when you want to be part of the game changer, you need to be aware what are the data science stages which are involved here. There are some stages which are also called as a data science life cycle. Right from the discovery of the data to the optimization of the data, you need to continuously train the things, continuously improvise and improve the things, and eliminate the noiseful data and arrive at the quality data to do the proper analysis and judgments. So data discovery is one of the first stage where you try to deal with the structured, semi-structured, unstructured data. In fact, I told in the beginning of the session only, we deal with those kind of data and push them into the data warehouse. But remember, you are not jumping directly into the data warehouse to prepare the data, because you don't want to get all the noise data into the system. You want to get prepare the data, quality data, eliminate the noise, eliminate the outliers, and make those particular data available for the right consumption. Over and above, you try to develop the models. This is where the data scientist role comes in. They develop the models, like it could be the financial models, inventory models, supply chain models, all business function specific models they try to develop. In fact, today, data science is becoming a very important investment in the recruitment industry as well. Today, I don't know how many of you know, every organization gets tons of resumes. How do they analyze the tons of resumes? What kind of learnings they obtain? What kind of intelligence they're trying to obtain? They try to measure the recruitment statistics associated to the region, college, gender, from where they are getting the huge amount of selects, why they are getting, and they try to analyze using the recruitment data models, which plays a very important role. The data scientists are the people who are giving that kind of intelligent input to the HR, who are able to make the selections based on the performance and also kind of a feedback loop. What did they get it? So once you model it, you try to validate against your hypothesis, and based on the outcome, you try to discard or accept. That evaluation is a mechanism for you to fit whether the model is fitting the need, model is able to achieve the goal or not. If there is a huge amount of variance, you reiterate and arrive at the stage where you are able to accept it. Once you accept, you try to get into the deployment mode where you try to pilot it and try to see the result. If the result is successful, then the full scale operation, full scale deployment happens, where data scientists can deploy the model, monitor the data, and run it for a long time and keep on getting the feedback loop so that they can improve the model and improvise it. So retraining the model or the machine learning model on continuous basis with the new set of data which is coming in will help to make the model to be more accurate, more, and generate more precision in the kind of outcomes what you're trying to generate. These are the important things. As I move on, just a couple of more slides to give you insights about what data science can bring in various industries. You need to be aware of the fact there is a huge amount of opportunities in the data science area. Irrespective of the industry segments, you see data science is becoming an integral part, because every industry will be dealing with the data, and if you want to derive the insights into the data, you need to have a data scientist. You need to have a data analyst. So that is needed, and you need to. So some of the core skills which are required in that particular area is linear algebra, probability, statistics, Python programming, R programming, and some of the visual libraries like Plotly, Flask framework, or the Dash framework, which are Python-based libraries which will provide you the lot of visual web analytics in place. So if you are typically taking the manufacturing segment, you see that manufacturing segment really looking out for the uh, predictive maintenance, because if anything which is running out of the warranty, and if they are not aware of it, what happens, the entire equipment will be under the loss. And if it is under the warranty, and if they get a predictive alarms to ensure that that particular warranty need to be extended, or people need to service that particular product, or then the entire equipment in a right shape will get it. And the ability to buy the product, the ability to forecast the scenarios, ability to telematics, utilize the telematics to troubleshoot and diagnose. These are all some of the key scenarios which are evolved as part of the manufacturing industry, which are becoming very, very mainstream, and data scientists are continuously playing an important role. In the retail industry segment, you see that a lot of inventory planning is taking into action, and you see many of the industries like Amazon, Flipkart, uh, you talk about Snapdeal. What happens is, like, they want to attract more and more customers through the channels so that they'll be able to cross sell their products or upsell their products. Cross sell is like you are choosing one product and you are trying to recommend other product. Upsell is you are trying to upgrade to the same level of the product to the new level. So likewise, looking into the portfolio of the customers, they do a lot of target campaigns. They try to target they try to do the influencer marketing. If it is a B2B segment, the target campaigns are done for the Yes, consumer segment. So there is a huge amount of digital marketing areas are also leveraged as part of the data science to strategize and give them the inputs. Healthcare and life sciences. Today, you see the patient related data in a very anonymous manner. The results are available in public. The COVID related data sets are available. They are asking and challenging the data scientists to come out with the meaningful models which can be more real time, which will able to establish the patterns, which will able to understand what is the first stage, second stage symptoms, and accordingly they will be able to diagnose. In fact, as I'm speaking, my team won a COVID-19 related uh, most promising innovation award in the recently conducted summer 2019, where we have demonstrated right from the CT scan images how you will be able to spot the regions and identify in the near real time whether the patient has got a COVID or symptoms or not. And this required a lot of information where we need to go and get the domain intelligence, CT scan related data inputs, and use the data models and train the data sets to identify the patterns. So that is becoming very, very prominent in the healthcare and life sciences. And even in the TTH, because because of the situations have influenced, what happens is the travel and hospitality segment is completely flattened out, and you have not seen a huge amount of revenues getting generated. There is a lot of outages which are resulting, and that patterns can be completely spotted ahead of time, and accordingly the some of the mitigation plans can be designed for them, so they can take the right level of measures. Similarly, in financial services segment, energy and utilities segment, you see huge amount of promising areas which are there to drive the risk analytics or the credit worthiness. In the utilities, you can look into the power usage or seismic data processing, the carbon emission related things. All these things are possibly available of the use cases which are getting constantly invested by the industries, and new and emerging models are getting generated to define the prescriptive actions based on the insights given by the data scientists. So finally, I want to touch upon this a few use cases which we have done for our customers. So there is a huge amount of customer analytics we have done for our customers. Basically, where customer requires to need a complete assessment and look into the ROI based evaluation. They want to understand how well their team was able to engage customers, what kind of sales patterns they have observed, what is the overall profitability and the loyalty of the customer in giving the extra business or repeat business to them. So customer analytics gives you the overall picture, and the models, the data scientists who are responsible for generating the models were very instrumental helping us to spot those particular patterns. In fact, that patterns once we spotted and given to the marketing, it really helped them to strike the conversation ahead of closure of the contracts and renew their businesses. Similarly, social media analytics plays an important role. Today, whenever we try to promote a product or a service in the marketplace, it is important for us to understand the mood of the customer. Getting that valuable insight will help us to know at a pilot stage itself whether this product will sell well or it gets discarded in the market. So, analyzing that hidden patterns and integrating with the meaningful insights with the necessary actions makes a very, very good proposition for the data science. The third scenario is about the sensor data analytics, what we have designed and developed. In fact, this is really emerged as a platform by itself. Now, where we have done the aftermarket sales, uh, what happens? So, if you have sold an equipment in different practices, aftermarket, that equipment will need to be maintained ahead of time. The equipment need to be looked into the warranty space. The equipment related service related requests need to be serviced at ahead of time, and you need to forecast these particular things and manage those. So continuously generating the data from that particular equipment through the sensor logic, we were able to manage to get the right level of inputs for the aftermarket team, aftermarket sales team, to the desired intelligence, so they can make the conversations with the customers and provide the services very, very proactively. Similarly, supply chain analytics. This is becoming a very, very needed area of investment by the enterprises today. You see lot of influence is there from the market dynamics, political dynamics, economic dynamics, social dynamics, which plays an important role into the entire demand and supply chain planning. So spotting those particular trends, understanding the cost and cost drivers or the revenue drivers will help you to make a meaningful decisions to gain the rightful constructs associated to the supply chain. And today you see there is a huge amount of emergence of the conversational bots or conversational interfaces, which is playing an important role in the computer vision, image processing, and natural language processing. And this conversation has got a lot of content which gets generated. If you are able to derive intelligence using the data science model and understand how the conversations are getting transformed, how the conversations are getting resulted, what kind of questions are expected, whether the bots are able to service the questions or not, will also influence and fuel the entire conversation interfaces to go to the next level. These are few things which I thought of touching upon, which essentially gives you a kind of a need how data science is really benefiting the industries, how data science play a very dominant role and provide huge number of roles and opportunities for yourself. And you can see that there are 8 different ways data science can add a lot of value to the businesses. It helps you to define the different actions and help in achieving the goals. It helps about better decision making. It helps in making the better practices and identify and spot the opportunities. Most importantly, it helps in quantifying the data driven evidences. So when the evidences are there, your meaningful actions are also and decisions are also validated, and so that you will be able to test the decisions, recruit the right staff, and also achieve the target audience appropriately. Today, if you are trying to choose the path of the data science in the engineering field, I say that there are huge number of opportunities for you, and the roles which are waiting for you are in these areas, like data scientist, systems engineer, big data engineer, research science analyst, database administrator, BI specialist, data engineer, data journalist, or software. These are some of the roles in the different industry prominently utilized, and you can challenge yourself to get into this particular segment of thought and orient in that direction. So this particular subject area has got a very good promise, and if you are able to really tap into that, you'll be able to make a great career ahead of time. I stop here, and I would invite any specific questions you are having right now. Rakesh,
Yes,
over
sir.
to you.
Yes, sir. There are few common questions like which one to choose, data science or artificial intelligence and machine learning? Because people are now, in a position to get into the degree, so they are in a confused state of mind. So which one to choose?
See, it depends upon the nature of the inquisitive nature what you carry. You need to question yourself. Are you good in spotting the patterns? Are you good in deriving the insights if there is a data set given to you? If you're good in spotting the patterns, deriving the insights from the data what you have, you should definitely choose a data science as a career path, because that is where your strength lies. But if you're good in developing the algorithms, or developing the algorithm which is iterative in nature, and move on, then you need to go for the artificial intelligence. So, and your ability to deal with the structured and unstructured data to define that algorithms is also very important to me. So if your scale of knowledge is more on Python, R, or any OpenAI frameworks or API.ai frameworks, if you want to really adopt, then go for the AI-based systems. If your scale of knowledge is more towards the spotting the patterns and deriving the data insights, then go for the data science. So just question yourself where your strength lies. Go with the strength, not with the way.
Tell something about IoT.
See, IoT is all about the Internet of Things. Primarily speaking, why IoT is used is where you have a different set of devices which can continuously generate the data based on the kind of a feed or the events in a non-intrusive manner. So let us say, for an instance, today you see that anywhere there is a sensor, IoT is there. It's a sensor-based analytics. So sensors are there to spot certain temperatures. You also have a gyrometric sensor in your mobile applications. Again, that is an IoT. The step count which is there in your mobile app is an IoT-based system. So it's trying to see there is a change in your mobile app behavior, or the moment is there, immediately it gives you a kind of a step count. So the IoT is all about looking into the sensors, and whatever the change it is trying to observe, that change gets triggered and that gets sent to the central system for processing. So it's not only in the small devices like a phone or something, but it's also there in the devices like air cooling systems, large manufacturing equipment systems, and the systems like farming, agriculture, where you can spot certain things ahead of time. The sensor technologies can help in understand the moisture in the ground or moisture in the kind of a sand, and help you to make the right time when to water the plants, when not to water the plants, and all those things. So the ability to give the decisions based on the uh, environment, or based on the change in the environment conditions, where the IoT plays an important role. And you also have IoT standards defined by the IEEE or defined by the ISO. There is also industrial IoT consortium available, which provides a lot of test beds for you to validate the things. And you can also exploit that particular area to a great level of depth. Now, only wanted to tell you that IoT helps in generating the sensor-based events. But what do you do with the data? And how do you spot the trends, spot the patterns, derive the insights? That's what again the data science people will come. Okay.
Give some light on cyber security as a course.
See, we are living in the digital systems, I would say, physical and digital systems. Today, the Industrial Revolution 4.0, when you're trying to talk about, it's all about the we are surrounded by the cyber physical systems, and we are digitally vulnerable. When I say more digital technologies surrounding you, there is a higher amount of vulnerability which exists around you. So it's important that you try to uh, anticipate these things. So if you try to look into the cybersecurity space, there is a this space has got a wide variety of the things. Uh, that endpoint monitoring, what you try to call about, when you try to see about the kind of a hackings which happens in that area, you need to provide the endpoint protection methods, prevention methods, rather than focusing on the forensic analysis after the event occurs. So huge amount of promise which is there in the cybersecurity space. Again, data scientists play a role in the cybersecurity area also, because that is a domain under which you're trying to operate upon. In data science, when you're trying to take, whether it is a cybersecurity or IoT, for them, it's a domain understanding is very critical. But the process for them to model and arrive at the insights would be almost the same. But the domain understanding plays an important role. Like similarly in the cyber physical system or cybersecurity, there is a huge amount of threats or the kind of hits which happens. They will try to identify what are the IPs which are getting hitting, and what is the endpoint protection trying to do, whether it is compromised or whether it is allowing all the traffic, whether it is trying to filter in a trend. So it is part of the prevention. But in the event occurs, when there is a result where your data is compromised, then they need to analyze and perform the forensic analysis. What really happened? And that entire causal analysis is part of the forensic data analysis, and they take all the possible evidences to look at. Cybersecurity is becoming a very important entity as part of the prevention mechanism people wanted to do. They are trying to introduce all the possible levers to drive the endpoint protection, container protection, and security levers at different levels and different zones, so they can protect the data and entry point at the different levels. And it's not only data at rest, but also data on the wire. They are trying to protect to a great level. So cybersecurity in the combination will be a lethal weapon in the industry today.
One more question I got. Kindly explain about something like how the structured data fits with how the semi-structured data fits with structured and unstructured data.
See, I told you, right, you have the 3 sets. In fact, I would say 4 sets of data, where the combination of the data, like when the entire data is in the form of the tables and the rows and columns in the tables, it's a structured data. When I say semi-structured data, 50% of your data in the structured mode and 50% of your data is unstructured in nature. So it doesn't mean that they are coexisting in the 2 different sources, but combining together forms one particular data set for you. Quasi-structured data is like 25% of your data is in the structured mode in the tables, while 75% data is in the unstructured mode. Again, the combination set plays a role. Unstructured data is where 100% of the data is coming in a very unstructured mode, which is a NoSQL mode also we call. And so they all need to coexist together. So it's not about they are fitting together, it's about they are coexisting together, and you need to establish the relationships by modeling the things, eliminating the noise data, and deriving the insights from it. Say for an instance, I have launched a product. That product launch, which I'm tracking in my database, I know which customers I'm targeting, what sales I'm trying to do. They're all part of my structured data. But people who bought that product and licenses, they are tweeting about my product. So that tweets which are coming into the product, what is happening? It's unstructured in nature. The Twitter's feeds are unstructured in nature. But there is also a possibility I'm asking for the feedback of my product from the source of the product itself or service. When I'm capturing the feedback, I'm trying to capture the feedback of my product in Excel sheets. So that is part of my quasi-structured data, where the feedback is coming in, but the product customer information is still there as part of the table. It's a combination. They all coexist. You need to establish the relationship to derive the meaningful insights. That's how it is.
Okay. These are the one more question is there. How that machine learning, artificial intelligence, and deep learning are related?
In fact, this is where I was trying to talk about, right? I try to talk about they're subsets of each other. Deep learning is a subset of machine learning. Machine learning is a subset of the artificial intelligence. And so basically, the level of algorithms, level of maturity increases deep when you are trying to engage with the volume of the data. So AI-based systems is the decision-based systems. We are trying to mimic the power of the human to an extent. But machine learning, when you're trying to look at, I told you, right, it's more focusing on the clustering and the classification area. In fact, I was trying to touch upon this classification and regression, where you're trying to look into the supervised learning methods. Unsupervised learning methods, you're trying to look into the anomaly detection and clustering areas. So the challenge for you is to understand when to apply machine learning, when to apply deep learning. You try to apply the machine learning methods when you have able to analyze the patterns, and when you're able to define the algorithms which will really meaningfully able to organize the things, where machine can make the decisions. Say for an instance, generally what happens in the industry, they have a level 1, level 2, level 3 kind of a support tickets. So if I want to analyze what are my support tickets, where can I optimize, and what I can do is I can define a machine learning algorithm which can understand what kind of tickets I'm hitting, what kind of classifications which are happening, and how I will be able to interpret and meaningfully derive the insights. So I can say which category of tickets can be automated better. That's one part of the machine learning. But over and above, if I want to remediate and automate that procedure, then the deep learning enhancements come. That's where the human brain symptoms plays an important role, where you are trying to make the judgment very, very nearly or similar to what human brain does. Getting closer to the human brain interpretation is where the deep learning plays a role. Getting the role of a machine perform some of the human functions, but not necessarily what a human brain decides at a raw manner, is what the machine learning does.
So these are all the questions, sir. Now I request Dr. Rajesh Khanna sir to propose the vote of thanks.
Thank you all.
What, sir? Rajesh Khanna sir? Venkateswarlu sir? Are you there?
Hello?
Sir, can you kindly propose the vote of thanks?
Hello?
Sir, can you kindly propose the vote of thanks?
There is a problem in my mic, sir. Please, you carry on, sir, please.
Okay. So it is really a insightful kind of talk that you have given. I think all the aspirants when they are thinking, they are in dilemma that what subject or what BTech course they supposed to join. I think they will be enlightened by your talk that what actually is what. Data science is what to do with data science, what to do with artificial intelligence and machine learning, and I hope people will be learning a great insight into it, and they will be taking a wise decision while filling the forms for the second counseling. And I hope we can interact more in future also. And thank you, sir. Thank you very much for your valuable time that you have spent with us. Thank you
Thank
very
you,
much.
and best wishes for all.
Yeah,
of
yeah,
you.
yeah.
Yeah,
Yeah,
thank you, Bala.
sir, Rakesh sir.
Yes, sir.
Sir, yeah, this is Krishna Bandi.
Okay.
Yeah, yeah, just I would like to say thanks to Bala sir. Yeah, just now, with this lecture, everyone can take decision. Students are a lot of confusion is there in students actually. Where we need to go either for data science or machine learning. They are in confusion mode actually. But definitely this lecture gives a lot of students definitely they will take decision based on this lecture. Thank you very much, sir. Bala sir, thank you.
Thank you. Thank you.
Sir. Thank you, sir. Thank you, sir.
Thank you.
Yeah.
Thank you very much.
Thank you, Chandra. Thank you.